still hot outside?
All right, section 2.1. Today we're going to start a chapter that's going to look a little bit less like the math we've seen prior. This chapter's section specifically is called Reasoning and Logic, and I find this absolutely crazy, and it happens in my life all the time, where things that are happening at home start happening at school, or things that are happening in one class start happening in another class, or something I studied in my Bible study shows up in church on Sunday morning. Does your life do that too? It's just crazy. So I kid you not, I did 5 hours of math on reasoning and logic last night at my house, because I have 3 children that had an assignment, and all of them are in the same class, but they can't do it at the same time at the table because they can't focus if the other children are there. So I do the assignment 3 times. 5 hours of reasoning and logic last night. And I'm telling my son, who is very frustrated, and he's very frustrated because this isn't math. This is what he's mad about. That if your picture of what math is numbers, you have a very limited view of mathematics. It's not what math is all about. It's like saying, what is English about? And your only perspective is grammar. Oh my word, grammar is, like, for me anyway, one of the worst parts about English. I don't like grammar that much, right? So if English was all about grammar, that would be a highly unfortunate situation. And math is not all about numbers. Math is about thinking logically through things. So we've done a chapter that's about problem solving. That was chapter 1. I know it's only 2 sections, but it's about problem solving and patterns, right? This chapter is going to be about logic. Okay, and in different ways. But specifically, this section is called Reasoning and Logic. And it's going to feel a little bit like, as my daughter said last night, this is really just English. Well, not really, but it does have a lot of language in it. So, language in a good way, not a bad way. Yes?
There's like...
Oh, goodness gracious. Let's see what's going on there. All right, so we need a little bit of vocabulary. This happens a lot at the beginning of new chapters, at least in this textbook. And the first thing we're going to talk about is what it means to be a statement. A statement is simply a sentence that's either true or false. Okay? Not all sentences are just true or false, but that's what it means by a statement. And so I'm going to give you an example. I ate eggs for breakfast. It's either true or false. It happens to be false. Did not eat eggs for breakfast this morning, okay? It's a statement that's true or false. So some of the things that you've seen before that are not statements, one of them would be questions, right? So a non-example would be something like this. What did you eat for breakfast? That's not a true or false. It doesn't make any sense to even say, is this true or false? It's a question. It's not a statement. Another non-example that's pretty common to be used here is what we would call a command. It looks something like this. Eat your breakfast. Common command in my house for the 10-year-old. Sit down and eat your breakfast. Okay, this isn't true or false, so it's not a statement. Okay? Negation. Negation is the logical opposite of a statement. So if a statement is the letter P, then the negation has got a tilde in front of it, P. Okay, tilde P. It means not P. You're going to see a lot of overlap. If you've taken contemporary math, and I know a couple of you have at least because you took it with me, there is a chapter in contemporary math that overlaps with this. Not everything's the same from resource to resource, but there is an overlap. Okay? It's written tilde P. Okay? So for my example above, the one that was a statement, that's the first one, what is the logical opposite of I ate eggs for breakfast? I did not eat eggs for breakfast. And so often we see just the word not showing up inside of negations. Okay? So, I did not eat eggs for breakfast. Okay, so negations are pretty straightforward when we have simple statements like this, where we can just stick the word not in them. I mean, they are. And to be honest, those are the kinds that my kids were dealing with last night. In every scenario that they had, all they had to do is stick the word not in after is. is, tempted, is not. It happened every single time. Okay, not all statements are that simple. Okay, some statements have what are called quantifiers in them. Now, there are two types of quantifiers. There's universal quantifiers, and then there's existential quantifiers. Universal means they're all-encompassing. So you see phrases like all, every, no, none. These are the kind of statements that generally get us into trouble. They say something like, you always do X, Y, Z. Do you really? Right? Do you always pay attention when you're driving? Do you always call your mom back when she calls you? These are usually statements that are really difficult to actually follow through on, right? Right? Or when you say to someone, you never, something next, right? Maybe you never text your mom back when she calls you. I don't know, whatever it is. The always and the nevers, these are those really strong statements. Existential quantifiers are things like there exists some, at least one. So they occur, they exist, but they don't occur all the time, is the general premise of them, right? So if you think about these always, never statements from the first one, the quantifiers, and I'll give you an example of one. Let's do one. I can't think of what I have. I'm going to write down what I have. All boys love their mama. Sometimes I wonder about the one in my house, but him aside. So if this is a statement, then in order for it to be true, every single boy would have to love his mother, and all it would take for it to be false is one who doesn't. Are you with me? One single one being not in that category, whatever that category is. Here it's loving their mom. Existential quantifiers mean that you've got this word some. Now, it doesn't necessarily mean that it couldn't be all, but it's a much softer statement, right? Sometimes you forget to do X, Y, Z. Sometimes you don't do this. Sometimes you don't do that, right? So it doesn't give this harshness to it. It's got a much softer statement. And so we end up with something like this. Some people like swimming. Now here's the deal. When we created negations over here, I mentioned the fact that it's really pretty straightforward when we don't have complicated things going on. We just stick the word not in somewhere and make it make grammatical sense and we're good to go. Well, when we have universal or existential quantifiers, we have to be a lot more careful in creating a negation. Okay? So over here, for example, I mentioned, not this one here. I mentioned all it would take for the first statement, all boys love their mama, to be false is one boy not to. I don't need all of them not to make this statement false. I just need one. One single example. It's like what you did when you were creating counterexamples. All you need for that sentence of math to be false is one example where it doesn't work. It's a counterexample situation, okay? So when we create these negations, we're a little bit careful. We have to be, or we're going to make mistakes. So here's an example of one. We've got all dogs go to heaven. So the word all needs to change. Okay? It's going to have to change. And in particular, what happens is that this universal quantifier all needs to change into an existential quantifier. So all has to become some, or there exists one, or something like that. Okay, we have to have this trade-off of the type of quantifier. All cannot become none, because those are both universal quantifiers. Okay, so all is going to, I'm going to write some on this one. You're welcome to write there exists at least one, any of those are fine. I'm going to write some. And then what follows, it has to be the statement that's the opposite. The first statement said all dogs go to heaven. What's the opposite of going to heaven? Well, at the very least, not going to heaven. Okay? We're going to go with not go to heaven for now. Okay, so this is dogs we're talking about. We're not talking about people. So it's not an either or statement we need to be discussing really, right? That's not the point. The point is to create the difference. And so this is going to be some dogs. And what would we say? Don't. Okay, so I am going to get that not in there. I'm going to put the word not so we can see it. Do not go to heaven. Feel free to do a contraction if you'd like. All it takes really, though, is one. I don't have to put the word some. I could say at least one. There exists one. Some dog. There is one dog that does not go to heaven if I want to negate this statement. Okay. By the same token, if my trade-off when I'm doing a negation for an all, right, a universal quantifier has to be that becomes an existential, I have to do the same thing down here. Some. Some needs to change. And it doesn't need to change into another existential quantifier. It has to become a universal quantifier. And I have two choices. I'm going to show it to you both ways. There's usually one that feels more grammatically correct, but they're both correct in terms of logic, okay? So the word some can become the word all, or the word some could become the word none, right? So some becomes a stronger word all, or some becomes the opposite word none. Are you with me? Okay, we're going to do all. This statement says some of my classes this semester are hard. So I changed it to all. Now what's the opposite of the fact that my classes are hard? Be careful. They're not hard. And here's one where we do have to be careful. I want you to really think about your classes. Can you always categorize your classes as easy or hard? Well, not necessarily. Some are sort of in the middle, right? Some of them you might not even use one of those adjectives at all. You might say something like, they're just time-consuming. Or maybe they're boring, right? It's not a binary operation. It's not an either-or. Now, if we went up to the first one and we talk about heaven, and we're talking about our eternal souls, right? From the Christian faith that we hold at this university, we would say heaven or hell, and that'd be it. And there'd be nothing else to discuss. It is an either-or. But that doesn't even make sense in terms of classes. Are you with me? Okay, so we would say all of my classes, and what did you say, Ty?
Are not hard.
Yep, this semester are not hard. Okay, so this is one logical negation. I mean, this is, with logic, it's correctly negated. The other one is that we can change it to none. So this one says, some of my classes this semester are hard. If I change this to none, I don't have to change anything else in the original statement because none is already negated the some. So when I change this and I say none of my classes this semester are hard, I also have a correct negation of the original statement. Now, if we just read these two, the second one feels more natural to say. The first one's right, that's great, but the second one is more like the way we talk. Okay, so there's usually one that feels a little bit more like right, but these are both right. Okay, ready for the next slide? Now, we're going to see what are called truth tables come into play. So truth tables are a way to evaluate whether statements are true or false from a kind of a rigid pattern kind of form, okay? Sometimes statements being true or false are very straightforward. It's easy to do it anyway. Sometimes it's not as easy to do, and so we're going to create sort of some structure behind that. So these are used to show all possible true and false patterns for a statement. So if we have negations, so here's what a truth table looks like. We're going to have a column that has our statement, in this case P. And then we're going to have the negation of P, and it's going to look like this. Okay? Column is P, whatever my statement is, tilde P, that's the negation statements like the ones I just wrote. There's two possibilities for a statement. This is how we defined a statement. We said statements are either true or false. Right? I ate eggs for breakfast. It's either true or it's false. There's no gray. This is binary. It's one or the other. It can't be like, well, I kind of ate eggs for breakfast. What would that even mean? You kind of did? No, you either did or didn't, right? It's true or false. All right. So think about it with me. If my statement is true, what would its negation be? False. And if my statement is false, then its negation is true. So negations just reverse things in a truth table. Truths become falses, falses become truths. Now, this is all leading up to the next part where it's that we're going to combine statements together. Okay? So a compound statement is two statements that are joined with connectives like and, or, and if then. So and means two statements at the same time with and between. Or is two statements with an or between. If then has the if at the beginning, the then in the middle, or it has the ability to be adjusted to say that. Okay? So those are the three types of statements. Another one that comes up sometimes that people get a little confused about is the word but. But means and. It's usually sort of contradictory things that we're saying, but they both hold true. For example, I got up this morning, but I was tired. Well, I did get up, and I was tired. I could say I got up this morning and I was tired, but it doesn't sort of have the flavor of what I'm trying to convey, right? But it does mean the same thing. I did both things. Are you with me? Okay, so if you see the word but, it really is just a synonym for the purposes of logic to the word and. So there's two types that we're going to talk about in this section, conjunctions and disjunctions. So a conjunction is a statement that has an and in it. Okay? And what I'd like to do is to draw you a truth table and talk about how we can create that truth table sort of to make sense. So a truth table for an and statement means I have to first have two statements, P and Q. And if I'm writing an and statement, the notation is an upside down kind of a V. You can think of it as looking kind of like a capital A without the middle for and, that's helpful, or as looking sort of like half of a capital N for the letter N in the middle of and, if that's helpful, whatever mnemonic you want to use. And then down here, I'm going to have P and Q in my table. Now, it is possible that both statements are true. It is also possible the first statement's true and the second statement is false. Or it could be that the first statement is false and the second statement's true. Or it could be that they're both false. Okay? Now, here's what I want to point out. The pattern will always remain the same for these. And we're only doing two-statement truth tables. I'm specifically talking to you two who took my class where in contemporary we do three-statement truth tables. We're only doing two-statement truth tables. So it's always going to go true, true, false, false, true, false, true, false. It's always going to look like that. This covers all the possibilities. And I'd like to create an example, and we're going to fill in the final column of the truth table for the and statement. I'm going to create this statement with a couple of individual statements. P is going to be the statement, I'm a mom. And Q is going to be the statement, I teach math. Okay, everybody good so far? Okay, and we're going to pretend in our head for a moment that we have guests in the hallway. There's 3 of them in the hallway. I'm going to be introducing myself. I'm going to walk in and I'm going to tell you, I am a mom and I teach math. Both of those statements are individually true. If you remember, I introduced you to my family in a picture the first day of class, right? And so if both of those statements are true and I tell you, I am a mom and I teach math, that is a true statement overall. So we get a T in the truth table right here. Okay. The next person who's going to come and enter our classroom from the hallway is going to be let's do Dr. Young. Do you guys know Dr. Young? Okay. So Dr. Young teaches over in the education department. Dr. Young is a mom. Okay. If you haven't met her, Kelly Young. Okay. So Kelly Young walks in and she says, I'm a mom and I teach math. Well, she is a mom. That statement's true. She does not teach math. She teaches early childhood, right? Classes and things like that, foundations and stuff, okay? So if she comes in and she says, I am a mom and I teach math, that overall statement would be false. That's false. Okay. Person number 3 that comes in is Dr. Drake. Do y'all know Dr. Drake? Some of you have met him. So Dr. Drake's office is just around the corner from mine, okay? Dr. Drake is in the math department. Dr. Drake is Nate Drake, which I think is one of the coolest names. It sounds like a superhero like Clark Kent. Okay, I think. Nate Drake. So Nate walks in, Dr. Drake walks in, and he says, I'm a mom and I teach math. And you would be like, no, clearly you're a guy. This isn't working for me, right? This is a false statement. All right, last person who's going to walk in, and he's going to end our conversation today, is Dr. Thomas. Dr. Thomas walks in. Okay, you've seen him all around campus. You know Dr. Thomas, president of the university. Dr. Thomas, Heath Thomas, this guy, and he walks in and he says, I'm a mom and I teach math. Well, he's not a mom, he's a man. This isn't going to work already. And does anybody know what he did teach when he taught? He mentioned it in Convocation Chapel on Wednesday. Old Testament. He's a religion professor. Okay, so the individual statements themselves are both false, right? This is a false statement as well. So in order for a conjunction to be true, both individual statements must be true. And we will pick up next time with disjunctions or statements.